All right, this is lesson 4, proportional and non-proportional relationships, and we're going to be able to identify them from a table. So just to get started, what does it mean to be proportional? So to be proportional, a change in one quantity results in a direct change in the other. So something happens that changes the other quantity. If a relationship is proportional, all the unit rates are going to be the same. If it is not proportional, all the unit rates are not going to be the same. What can we do to find this unit rate? Well, this is what we've been doing the past couple of days. So we're first always thinking about dividing. Whenever we are asked to find the unit rate, we divide. And to find the constant of proportionality, we are always going to divide y by x. So there's actually a formula to help us with this. Remember, our constant of proportionality that we talked about is given to us. We use the variable k. So our formula to find the unit rate or to find the constant of proportionality is k equals y divided by x. So it's always important to know what our y is versus what our x is. So in our first table, the first thing I'm going to write down is my formula, k equals y divided by x. Now, this table is really nice because it tells me exactly what x is and what y is. This setup, even if it's not labeled with an x variable, y variable, your x is always the first column and your y is always the second column. So be careful when you go to plug these in. When we are solving these, we have to make sure we check the unit rate of every single x and y pair. So I'm going to go ahead and do the first one. So my first one would be y divided by x, so 5 divided by 1. Next one would be 10 divided by 2. Well, 10 divided by 2 is also 5, so far so good. Next one would be 15 divided by 3. Well, 15 divided by 3 is also 5. Remember, we have to check every single one. We can't just assume. And then 20 divided by 4. Well, 20 divided by 4 is also 5. So this would be a proportional relationship because all the unit rates are the same. We're going to take a look at table 2 now. Now, table 2, this chart is set up just differently. It's horizontal instead of vertical, but it's the same exact thing. X is the first row, y is the second row. So I'm going to write down my formula again, k equals y divided by x, and I'm going to try all of my values. Now I have 1 over 0, which is just, we're going to leave that blank. We've got 3 over 1, which is 3, and 5 over 2. Now that is not going to be 3. It's going to be a decimal. This is actually 2.5. Now, since these don't match, or even because the first two that I did, this 1 over 0 and this 3 over 1 don't match, this is not proportional. As soon as I have two of my values that are not matching, I can immediately say it's not proportional. Okay, next page. So example 1. A new self-serve frozen yogurt store opened this summer that sells yogurt at a price based on the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and then this is what they found. So we're going to determine if that cost is proportional to the weight. So I'm going to underline what we're finding. Determine if the cost is proportional to the weight. Now, just like with all of our unit rate questions, the first thing we need to figure out is what our label is. But when we look at our table here, it doesn't give us explicitly an x and a y, but don't worry, we're going to mark it down. Remember, our first row is always x, and our second row is always y. So our formula is k equals y divided by x, and then we're also going to figure out what y and x are in the context of the problem. Well, y is the cost or money, and x is the weight in ounces. So that's my label, just like what we were doing with unit rate. So now I'm going to go ahead and I have to check every single ordered pair. So I have 5 divided by 12.5. When I put that in my calculator, I'm going to get 0.4. Same thing for the next one, 4 divided by 10. And I'm just going to keep going down the row and checking all of my values to see if they give me the same thing. 2 divided by 5, that is also 0.4. 3.2 divided by 8, and I'm doing all this in my calculator. That also gives me 0.4. And my last one, 6 divided by 15, is going to also give me 0.4. So when we take a look, every single one of these gives us the same exact constant of proportionality or the same unit rate. Does everyone pay the same price? So yes, when you break it down, they all pay the same price. So yes, because all the unit rates were the same. And then it asks, is the cost proportional to the weight? Well, yes, and the reasoning is the exact same thing that we wrote above. Yes, because all of the unit rates are exactly the same. And when you're explaining in words if it is proportional or not, you need to have this reasoning here. All the unit rates are the same. Okay, let's try this one again. Try another example. So it says, in the back of a recipe book, a diagram provides easy conversions to use while cooking. Find the unit rate. All right, so the first thing I want to figure out here, now this is no different than our table, it's just 2 line graphs, but the same thing. X is on top, Y is on the bottom here. So X is my first row, Y is my second row. But be careful when I go to plug this into my formula, Y is on top and X is on the bottom. So Y divided by X. In my label, this is ounces divided by cups. I'm going to go through and check every single one. Now, 0, 0 is an exception, so I'm just going to leave that one out. I'm going to start with my actual numbers. So 4 are actual positive numbers, because 0 is technically neither. So 4 divided by 1/2, if you want to write that as a fraction or a decimal, does not matter. 4 divided by 1/2 is going to give me 8. Next one, 8 divided by 1 is also 8. 12 divided by 1 1/2 is also going to give me 8. And last but not least, 16 divided by 2, that gives me 8. So that means that my unit rate is 8. If they were not all the same, there would not be a unit rate. You would just say no unit rate, okay? Is the number of ounces proportional to the number of cups? Well, since the unit rate existed and they were all the same, then this is proportional. So we're going to write the same thing. Yes, because all the unit rates are the same. Okay, good luck on your homework.